I'm non-zero sum James, your companion on this exploration of win-win games. This next post, Graviton, deals with Emergent Gravity, and is one where you'll really want to visit the page to enjoy it fully. Beware though, the simulation at the head of the post is mesmerizing, and you might find yourself lost fiddling with the dials and exploring life forms that emerge in your digital universe for longer than you'd intended. How the simulation works and what it means is explained throughout the posts, but in short, like Conway's Game of Life, it's a simulation of a complex system arising from very simple and quite random rules. Dials at the base of the sim allow you to tweak the constants that influence the nature of reality in this universe. And you can see how, though balance is required for any particular universe, many complex patterns can arise from very different interdependent parameters. The above simulation is the result of some very simple rules. Randomly positioned points, each assigned one of a number of colors. Each color has a randomly assigned but consistent attraction to or repulsion from each other color. As with Conway's Game of Life, we see that from these simple rules, complexity arises, and specifically we see gravitational forms and patterns that feel like bodies, cells, or atomic oscillations. A speculation. What you are about to read is no doubt a stunning example of the Dunning-Kruger effect. That is, that I have done so little actual study of theoretical physics that I am unaware of the extraordinary magnitude of my ignorance on the subject. Nonetheless, I will go forth with the confidence of a tone-deaf X-Factor participant. If you wish to make an apple pie from scratch, you must first create the universe. Carl Sagan. Gravity is a key missing piece in the quest for a grand unified theory. And indeed, I stumbled on this subject not out of a burning curiosity about gravity, but by trying to conceive of a logically coherent model where something could come from nothing. How order could arise from chaos. The philosophical materialist foundational dilemma. What is nothing? As I mentioned, I was trying to develop this idea with no physics education, so I enrolled the help of Lawrence Krauss, inasmuch as I watched some of his lectures on YouTube. In his talk, A Universe from Nothing, he makes a nod to the problematic nature of nothing, stating, "Philosophers and theologians know a lot about nothing, and require you to talk about it in the way they like." Lawrence Krauss. Now, if you're feeling masochistic and want to know how philosophers talk about nothing, try Heidegger's essay, What is Metaphysics? It turns out that the nothing of physics, that being the emptiness of space, is in fact a bubbling brew of quantum fluctuations. This actually aligns with the philosophical nothing, better described as chaos, something immeasurable, God's dark materials. A dark, illimitable ocean without bound, without dimension, where length, breadth, and height, and time and place are lost. John Milton, Paradise Lost. What is something? Something, in order to be distinguishable from nothing, needs to be measurable, and so needs to accumulate in some way, whether it's by combining with other things, or replicating, or developing consistent properties. What we are looking for is the simplest form of self-ordering, because as soon as we have any simple self-ordering process, order can grow indefinitely. So what is the simplest thing that might self-order? How about a very weak force that draws points together? Wait, that's cheating, right? That's simply positing what we're trying to explain, gravity. To explain that, we need to find something even simpler. So how do we make something simple even simpler? We eliminate specifications. 1. Gravity requires particles with mass. So let's do away with that. It sucks. So let's do away with that. Gravity has one particular measure of force. So let's lose that. So what are we left with? 1. A field of randomly positioned, zero-dimensional massless points. 2. That move toward or away from each other. 3. With arbitrary relative force. These are the conditions of the simulation at the top of the page. The simulation was essentially a proof of concept that, given random relative forces, gravitational bodies will emerge, and the results confirmed what I'd expected. But it seemed to show something even more complex than that. These simple rules created complex structures. The apparent gravity was actually just a byproduct of the aggregate of those individual particle forces. It was exciting, but I had a sneaking suspicion that there might be one of those annoying facts or observations in physics that made my position untenable. Is any of this real? It turns out, perhaps. I found that physicist Eric Verlinde, in his talk Gravity Doesn't Exist, held a similar contention that gravity is not actually a force, but a byproduct of multiple different microforces, in the same way as the force of a magnet is a byproduct of the alignment of the magnetic fields of the particles. Verlinde relates gravity to temperature, which is a byproduct of the average kinetic energy of particles. He says that while we cannot measure the temperature of a single particle at the microscopic scale, we can measure the temperature of a group of particles and other macroscopic phenomena such as pressure. Also, we can predict, based on the law of entropy, explored in the previous episode, that gas will flow from a high pressure area to a low pressure area, and the temperature will transfer from hotter areas to cooler areas. He suggests that in the same way, gravity is a byproduct of the alignment of the quantum particle fields. Emergence from entropy. Imagine a world where heat did not transfer in a predictable way. You dress for a nice day out in your t-shirt and shorts, only to find that 2 steps out of your door the temperature drops to negative 30 degrees. Then another step you find you are roasting to a fiery death. Of course, given there is no heat transfer, the idea of roasting ceases to make any sense at all, but you get my point. If we did not have an entropic process that created consistently temperate environments, there would be no place we could live, at least not as we know it. So the law of entropy actually turns out to create the predictable, consistent conditions on which the ascension of life depends. It forms a substrate of uniformity, eking out a niche for a new phenomenon or dissipative structure that, through its contribution to entropy, creates a new substrate on which further phenomena can arise. This mechanism of emergence will be the subject of the next part.